Welcome back once again. So today we are going to learn about JavaScript asynchronous behavior using a real world example. So we have the chef's busy kitchen here. So what we are going to learn, since in the last video we learned about how JavaScript handles asynchronous code using chef with single burner example. Today we are going to take a real order example and see how the chef, which is JavaScript, handles the meal preparation. We'll explore how the meal is prepared and then compare that to the JavaScript elements like event loop, callback queue, call stack, and the web APIs. So let's cook some JavaScript. So here we have our chef world. We have our chef here, we have our helper, here is our burner manager, here is our burner manager queue, this is our single burner here, and the food order list. Okay, so now this is the JavaScript world. This is JavaScript. The helpers here are web APIs. We have event loop, which is burner manager. We have callback queue, which is the burner manager queue. Okay, then we have the call stack, which is the single burner, and the JS code, which will be executed. So here comes the order. Let's say a customer places an order for a full meal: pasta, garlic bread, and salad. We have 3 tasks. We have to cook pasta, we have to toast the garlic bread, and we have to toss the salad. So how you think the chef can handle these? We have to note that the chef has only a single burner, right? So let's see how the chefs can handle these. What the chef can do, delegate some tasks to the helper like cutting vegetable or like toasting the garlic bread. Okay, then the burner manager will keep a check of whether the tasks from the helpers are being completed or not. If the task being completed, then what happens is the event loop, which is the burner manager here, will check like if the single burner here is empty or not. If the burner is empty, it will take the task here and like put that to the call stack. If it is not, then it will put that to the callback queue, and this way like it can handle all the process efficiently. So let's break it down. So we have 2 tasks which can be delegated. We have task 1, which is toast the garlic bread in the oven. We have task 2 to chop the veggies for the salad. So what we can do is we can put all those 2 tasks to the helper, and the helper will handle that. The helpers are busy in the background, okay, but the chef burner is free again and the boiling pasta is done. We have like handle both the operation efficiently. So once the task being completed by the helpers, we have to take those tasks and put that to the call stack, which is our single burner. So what happens here? So when the helper finishes their task, they let the burner manager know that the garlic bread is toasted. So once the task being completed by the helpers let the burner manager know that their task has been completed. So now what's the task of the burner manager? The burner manager has 2 tasks. So the first is like, is the burner free? If the single burner is free, it can take those tasks and put that to the call stack. But if the burner is not free, so it checks that are the tasks in the queue. So we have to keep those tasks from the helper in some queue. So here we have our burner manager queue. So the first thing is like burner manager checks, the burner manager here checks if burner is free. Okay, if it's free, then like it puts the task to the call stack, which is the single burner. If not, it takes those tasks and put that to the queue here. If the burner manager is not free and the helper has completed their task, so what the burner manager do here is take those tasks and put that to the burner manager queue here. Now what happens is the event loop ensure that the tasks from the queue are added to the call stack, which is the single burner, once the call stack is free. So now the burner manager again checks like, is it empty? If the call stack is not empty, it keeps waiting, but when the call stack is empty, it like take task from here and put that to the call stack. Then again it takes task from here and put that to the call stack. So suppose like we have here completed veggie, it will be put that to the call stack here. Similarly if we have toasted garlic bread, it will be again put to the call stack using the burner manager, which is our event loop. Okay, so this is the chef world here. This is the chef here, and using all these individual elements cooperating with each other, we have our helpers, we have our burner manager queue, call stack, food order list, all these cooperatively working. The chef can take a full meal order and process that efficiently. So here we have cooked our salad, the pasta, and the garlic bread. Okay, so this is how JavaScript asynchronous model work. Keep things efficient by letting the web API handle background task while using the callback queue to stay organized. And finally, relying on the event loop to keep running things smoothly. So next time when you hear someone mention call stack, web API, or the event loop, picture our busy chef and their helpers. Understanding this analogy will make JS async behavior less intimidating. So please like, share, comment and subscribe if you find this video helpful. I'll put a link in the description with a detailed reading of all the stuff I've mentioned here. Thanks for watching.